paper with, as you can see, they array the same mass. Alright? So now if I take one of the pieces of paper and crumble it all up, you can see that it's still of the same mass. So now, if I were to drop these two pieces of paper from the same height, which one would hit the ground first? Because, according to various physics formulas, such as a favorite of mine, since going down the same distance and at the same acceleration of 9.8 meters per second squared, they should hit the ground at the same time. Alright, so let's make a prediction. Which one hits the ground first? Crumbled walls or the not crumbled paper? Alright, let's do this. As you can see, the crumpled paper hit the ground first. But why?
The reason why the crumpled ball hits the ground first is because of F equals ma. So the net force on the two papers is going to be the force of gravity and the force of drag. And the force of gravity, as we all know, is mass times 9.8. And the equation for the force of drag, or the drag force, is 1/2 the density times v squared times the drag coefficient times the surface area. So the drag coefficient is kind of like the moment of inertia, how there's different inertias for different objects. So a sphere is going to have a drag coefficient of 0.47, and a cube is going to have a drag coefficient of 1.05. And since the two papers have the same mass, they're going to have a different acceleration with a different drag force. And also, since the crumpled paper has less surface area than the paper that's not crumpled, the surface area is going to increase, and that's going to have more air acting on the paper, which is going to increase the drag.
So, how does this apply to us in real life?
I don't know.
Well, think about how parachutes work. Since parachutes have a large surface area and a large drag coefficient, the person using the parachute will fall at a much slower acceleration and will get there in a lesser amount of time. Therefore, they won't fall as hard or as fast to the ground, so they won't die.